Math 120. So this is the first of our actual videos that will be content that we need for our course. This is actually going to be for the review for Module A. So you know that you see when you look at Module A on Lumen, there are 3 different topics that are in there that are review for Module A. So those homeworks are optional. They won't be part of the test, but it is foundation that you have to know to do the rest of Module A. So it's solving linear equations, solving and graphing linear inequalities, and also the beginning of talking about graphing and slope. So you really need to know those topics in order to move on and do what else we need in this module and beyond. So you know that there are review for Module A notes up on Lumen, and I've also now put up the completed version of those notes. So in this video, I'm trying a new program so I can have the notes up on the screen and me also, and then when I'm doing something on the whiteboard, I'll switch so you just see the whiteboard, so it's a little bit larger. But this way we can kind of follow along with the notes, whether you have them printed out or later on you can look at them online also, but you can see them here. Okay, so the first page of these, and you'll see that it's pretty long, it's 10 pages. I think the Module A notes themselves are about 20-some pages. There's a lot of information in there, a lot of words, because normally, you know, in an in-person class I would be talking, so I try to put that in the notes for this online course as well. There are a lot of examples. Okay. So you see this first page of these notes talks about what a linear equation is, the steps to solve a linear equation here, and some information about what makes an equation a conditional equation, a contradiction, or an identity. Okay, so I'll kind of let you, take some time to look those over on your own as well, but just in general, an equation with one solution is called a conditional equation. So if we get an answer of x equals -3, that's a conditional equation. There's one answer, one real number, and only one real number that makes that equation true, that makes the two sides equal. An equation that's a contradiction has no solution. So if I had something that said 5 equals 3, if that's what I end up with, then that can never be true. There's no number that would go in for x into my equation to make it true. And then the third thing we can have is an identity where any equation or any real number makes that true. So if I had x plus 2 equals x plus 2, it doesn't matter what x is. If I add 2 to it on one side and add 2 on the other, those two sides are always going to be equal. So those are our 3 options. All right, so if we look at our first example down here at the bottom of the first page, I have a linear equation here. So just thinking about those steps, we always want to do the distributive property first. Remember, distributive property means that I take whatever's outside the parentheses and multiply it by everything inside the parentheses. Remember that this 2 in this case would not get multiplied by this -17 because that's outside of the parentheses. We do the same on both sides. Once I've done that, I look at each side individually and I see if there's anything that can be combined. Okay, so in this case, the -6 and the -17 are like terms, so they can be combined. Now in that point, I'm not saying I'm going to add 6 to both sides to move it around. I'm not adding 6 twice over here, right? I'm being really careful that if I'm just working on one side of the equation, I just do what it says. If I want to move something from one side to the other, that's when I would add or subtract. Do the opposite of whatever's being done. Okay, so hopefully this should be review from either from Math 95 if you took that at TC3, or from a previous math class at another college, or if you just tested into Math 120, you would have had this in whatever previous math class you took. So this should be review. If you're having a hard time with this, make sure you take some time to look at it. Look at the videos provided in Lumen that come with the examples there, and also come see me for extra help. Okay, so I just want to talk for just a minute about how we go through math texts or math work like this if we're not sure. So let's say you're not sure how to do this. You tried it on your own, you got stuck, so you look at my completed notes. Okay, so you're looking at this. It's not enough to just say, oh, okay, so we went from this step to this step. You have to know how we got there. So if you aren't sure where the 2x came from, or you aren't sure where the -6 came from, you have to stop and figure that out. Because if you can't replicate that on your own, then you won't be able to do the problems on your own. So it's really important to think about that. If you get confused and you think, I don't know where this -6 came from, well, don't just panic and give up. Let's look and see, here's the equal sign. So we're just looking at this side. Now, where could that have -6 come from? Look at what you still have that's the same. Look at what's different. Think about what you did. Think about where that could have come from. And then moving down to the next step. Okay, where did this -23 come from? Well, I see I have 2x. Something happened with these. If I take -6 and subtract 17, I get -23. Okay, so just take it step by step. If you get to a step, let's say you weren't sure where the 23 came from, the -23, but then from there you could follow it. Well, just put a little star here, make a note, and then email me or jump on the Zoom office hours to ask me about it. Okay, but that's really how we need to study math. We need to know what every step along the way does. That's why I'm suggesting that you either print out or just look online at the blank notes, go through the information, try those examples, and then check your answer with the completed notes or on these videos also. But give yourself time to try it a little bit also. So when we go through this, we solve for x, we find that x is 6, so this is a conditional equation. I did not write out the checks for most of these problems, just for time and space considerations, but you should check these. Whenever you have a conditional equation, you should check it. You don't have to write out the check if you don't want, but even if you just take this and plug the left side into your calculator, exactly as it is, with a 6 in place of x, see what you get. You get -11. Do the same thing on the right side, make sure you get the same answer on both sides. That tells you it's true. If you got -11 here and -15 over here, that means that 6 does not make these two sides equal like you thought it did, so there must be a mistake. Okay, so you can go back and fix that. If your check doesn't work, also check your check, right? Maybe you made a mistake in here and they really are the same. Okay, so I'm gonna leave the second one and the third one for you to try on your own. And again, you can go back to the blank notes to check your answers for those. I wanted to look at some of these that use the LCD method, because depending on what course you were in before, you may not have had a ton of experience with it. So I will let you read through this again on your own, but let's just go through it with this example. So I am actually going to switch to just have the whiteboard after I write down this problem for myself. So we're going to have 3x over 2 plus x over 6 equals -5/3. Okay, so we have this problem, and we know that we need to use this LCD method because I have fractions. Okay, now later on in the course we'll have fractions where we even have x's in the denominator. Right now we have just plain numbers in the denominator. So there are a couple things I could do with this. Like, these are like terms in a way because they both have x's. I can't add them right now because they have different denominators. So I could change them to have the same denominator, so then I can add and subtract the fractions. That works. Okay, that's one thing to do. Another method we can use, though, is what we call the LCD method. And this method is going to allow us to take a kind of, crazy looking equation like this with fractions, and in one step, we're going to get rid of all the fractions. So we just have a nicer linear equation with no fractions. So we first have to figure out what the LCD is. Remember, LCD, or we can call it the LCM, is the least common multiple or least common denominator, whichever one we kind of use in context. In other words, if I were counting by 2s, counting by 6s, and counting by 3s, what would be the smallest number that I would come up with in all of those lists? And that would be 6. Right? Because if I start counting by 6s, I get 6. If I count by 3s, 3, 6, 9. If I count by 2s, 2, 4, 6. Now, the L stands for least, okay? Really, using the least common multiple makes things easier for us, but it's not necessary. We could have used 12, okay? That's not the least common multiple, but it is a common multiple. 2, 6, and 3 go into it. It'll just make our next step have larger numbers, but they'll divide out eventually to give us the same answer. So now if we were going to change these all to have the same denominator and work with the fractions like that, then we would want to change all these to 6. We're going to do something a little bit different. And if you look back at the notes that we were just looking at right above this problem, there were some steps. It'll take you through those steps. So what we're going to do is we're going to multiply every single term by the LCM. Now, in this case, all 3 of my terms are fractions, right? But even if they weren't fractions, let's say this were just an x or just a 5 or whatever, we're multiplying every single term by the LCM. And because these are fractions here, I'm going to write my LCM as a fraction too. I'm just moving this plus sign over so I have a little room to sneak this in here. So I'm going to multiply this term by 6 over 1, means the same as 6. Multiply this term by 6 over 1. Multiply this term by 6 over 1. Okay. All right, so now what I can do is I'm going to be able to cancel out the denominator of each fraction with the numerator, okay, or by LCM, I should say. So if you remember how this works, let's say I'm multiplying fractions, and I have 5/6 times 3/4. If you remember, we can either multiply straight across the top and the bottom, and then cancel at the end, or I could cancel whenever I have a numerator and a denominator that have something in common. So I could say 3 goes into 3 once, 3 goes into 6 twice. Okay, so hopefully that's coming back a little bit. That's the idea of what we're doing here. So with these 2 that we're multiplying right here, 2 goes into 2 once, 2 goes into 6 3 times. Then here, 6 goes into 6 once, 6 goes into 6 once. And here, 3 goes into 3 once, 3 goes into 6 twice. So I have canceled those out. Now, how did I know, or I should say, is it surprising that all of these original denominators canceled out to be 1? And the answer is it absolutely should not be surprising, okay? That's why we chose 6. We chose 6 because 2 goes into it evenly, 6 goes into it evenly, and 3 goes into it evenly. That's why it was our common multiple. If I had chosen the wrong common multiple, and these hadn't all canceled out to be 1, we would know then that we did something wrong. Okay? So I'm just going to circle what I have left. Remember, these 2 things were being multiplied, so now I have 3 times 3x, which is going to be 9x. Then here I have 1 times x. I'm kind of ignoring the denominators because if you look, they're all 1. Over here I have negative 5 times 2 is negative 10. There's no x over on that side. Okay. Now in this one step, I have gone from this mess with all these fractions to something that's equivalent but has no fractions. Very easy to solve, right? Combine these 2, 10x equals negative 10, divide by 10, divide by 10, x equals negative 1. Okay, we can check this again, just plug it in for x. Now, you might say, well, it's kind of a mess because of those fractions, plug it into the original, but you can do it on your calculator relatively easily. Okay, so that's this one. You can see that right there. There are a couple other examples on here of the where you can use the LCD method. So there's a couple there. This kind of puts some of those from the first and second section together. So you have to distribute. So always distribute first. Sorry, that's kind of in the way there. Always distribute first. So we distribute the 1/4 through. That's what I did here. I distributed the 7/8 through, cleaned it up a little bit, and then once I had a sort of cleaner version, in this case I actually kind of kept going with my fractions in these 2. I just kept them as fractions, but at this point right here, you also could have then said, okay, I'm going to multiply by the LCM, which in this case would be 16, and you could have gotten rid of them there. I kind of just got going with the fractions, but either way would give you that same answer. Okay, so the program I'm using right now, I'm using a free version of it, so I can only do 15-minute segments at a time. So I'm about there. So I'm going to stop this recording, and then I will come back and we'll work on inequalities.